All right. So, as promised, today, you got to smile. Come on. As promised, today we're going to do the quadratic formula. Okay. Good. All right. So the the paper you're getting right now is your homework for tonight. That homework has a total of 8 questions on it. I did go ahead. I did make a mistake about question number 7. So turn your paper over to the other side. I know, right?
There's a mistake on number 7.
Okay.
I don't even know what it is.
Okay. So in the original question, it says at liftoff, the space shuttle Discovery has a constant acceleration of 16.4 feet per second squared and an initial velocity of 1,341 feet per second. In the equation, you'll notice that I don't have 16.4 in there. I had 8.2 in there. So please cross out the 8.2 and change it to 16.4. Okay? So what you see on the front of that paper is nothing more than a quadratic equation. We've seen multiple, probably too many in some of your opinions, quadratic equations.
Yeah.
Okay? The question with any equation obviously is to solve, to find an answer. We've talked different ways that this can be done. We can do it graphically through Desmos. We can do it by factoring through either greatest common factor, ACB, factorable trinomial. There's multiple options. The quadratic formula is another option for doing it. Okay? If you are given the option to solve however you want, then you can choose. And you may not choose the quadratic formula. Full disclosure, I probably wouldn't either. But if I'm asked to solve with the quadratic formula, or if I'm asked to use what is called the discriminant, and we'll talk about that as well today, then we need to know what it is we're talking about. Okay? The quadratic formula is not something you have to memorize. So you see, yeah, it's long, okay? But you need to be able to utilize it. You have to know its pieces, parts to be able to put together. In order to do it, everybody needs a calculator today. So if you don't have a calculator, go ahead and grab one. If you have yours, take it out. All right? But you're going to need that. So really we're looking at 2 things. There's a couple different examples here, but really it ultimately breaks down to 2. Can I use the quadratic formula? And then can I get into this idea of the discriminant? And we'll talk about what that is. It's a part of the quadratic formula. Okay, so those are our goals. Solve and then use the discriminant. So we're going to start with the quadratic formula. So in all its glory, okay, there it is. It would be pronounced the opposite of b plus or minus the square root of b squared minus 4ac divided by 2 times a. That's a mouthful. Probably would write it down somewhere. This morning, I made the assumption that you guys knew what this symbol was right here, and they did not. Okay? So it's an addition and subtraction at the same time together. Okay? Here's why it's there. Next to that plus or minus, you see a square root. If I asked you to square root a number, for example, could somebody tell me what the square root of 16 is? You would say 4, right? Because 4 times 4 is 16. But you should also be thinking -4, because -4 times -4 is also 16. So when we put the plus or minus side by side, what we're really saying is, hey, there's not just one answer. It maybe isn't just 4. It could also be -4. So we'll have the ability to produce more than one answer. And remember, with a quadratic, we can get up to how many answers? We can get up to 2. We could get 2 answers. We could get 1 answer, or potentially we could get no answers, no solution. Okay. Part of this formula should look familiar. Negative b divided by 2 times a. Do you recognize that?
Yes.
As the as the well, it's part of the vertex formula. Yes, it has a name. Starts with an A.
I got it.
The
Symmetry.
Axis of symmetry.
I said symmetry.
Yeah, I was like, you're going to pull this out. All right. So that axis of symmetry formula, the opposite of B over 2 times A. What's up? You okay?
It's called the quadratic formula.
But it only has 2 answers. But oh my god.
Well, in some instances, quadratic, quad means 4. But really, when you're talking about powers or degrees, quartic is 4. Cubic is 3. Quadratic is 2. Sorry. I know you're not liking that answer. So it
was always quadratic.
Yeah, it is. But when you hear that prefix quad, I agree with you, because if you think like sides of a shape, quadrilateral means 4. But now when we talk about powers or degrees, all of a sudden now it means 2. Like, great, thanks a lot. Way to keep that, consistent. But it's not. So we're going to practice this formula today. We're going to practice it a couple times. I think you'll get the hang of it. Hopefully, we all can identify A's, B's, and C's out of a quadratic equation. Like if we took a general equation, y equals, it is of the form ax squared plus bx plus c. So if I had some equation, let's just say, say it was 4x squared plus 3x plus 6, the value of a is what? The value of a is 4, the value of b is 3, and the value of c is, okay. If one of those numbers happens to be missing, so let's just say it looks like this. What's the value of A? Still 4. What's the value of B? It's 0. Good, it's not there. And the value of C is 6. Okay, so this 6 is really still down there, and truly that's in the middle, but we don't write it that way. Okay, so if we're missing a piece, we have to understand which one is associated with which. So the A is in front of the squared, the B in front of the X, and then the C is that constant on the end. All right. So we're going to look at this one first. Like any quadratic that you could possibly solve, you must do something before you do anything else. You remember what it is?
Yes, you have to find the x by itself. You have to square root and stuff.
No. So it's pretty simple and straightforward. Say that again. Got to put everything to the same side. You got to make it set equal to what? It's got to be equal to 0. Okay. So we have two choices. We can either move the 6x squared and the 5x, or we can move the 4. Probably just move the 4. If you move the 4, what do you get? Well, you get that becomes negative. Everything else stays. So 6x squared plus 5x minus 4 equals 0. Okay. So that's not changed regardless of whether we were going to factor or whether we wanted to graph it or whether we're going to use the quadratic formula. All those would be the same. Is this something that you could factor? Do you know what method you'd have to use to factor that? Good. It'd be the ACB method, right? What's A? 6. What's C? Negative 4. So when I multiply them, I get negative 24. Could you think of something that multiplied to negative 24 and added to B, which in this case is a 5? You give me something multiplies to negative 24 that adds to 5. Got it?
And positive 3. No, positive 3. No, negative 3, positive 8. There you go.
That was painful. Yeah. It needs to be a positive 8 and a negative 3. Okay. So I could factor it, right? I could graph it. Check this out. If I graph this, let's come over here. If I graphed it, it would look like this. Graphed. Right? Pretty simple, pretty quick. Okay. How many solutions are there if I graph this? Looking at the picture. How many? 2. Do you know where they're located? Where are they located? On the x-axis, right? And remember, if I click on those, if I click on those, I should be able to get those answers. Okay? So I can see there's 2 answers to this problem, right? One of them's negative 1.3 repeated. The other one is 0.5 or a half. Can also use the quadratic formula to get to that same result. And so that's what we're going to look at today, knowing already that there's how many answers? It's already 2. Okay. So in order to do this, the first thing I have to do is I need to be able to substitute in everything that I see. Now, just like when I did the axis of symmetry, I'm going to start with this opposite of b. So in this case, right now, b is equal to what? Well, originally b is equal to 5, but I'm going to write -5. Okay, so x is equal to -5 plus or minus. And now under the square root, I need b squared. So that's going to be 5 squared minus 4, and then times it by a, which is 6, and c, which is -4. And if you have to, extend your square root sign so it all stays underneath there. Okay? And the whole thing gets divided by 2 times a, so 2 times 6. Okay? It's bulky, right? I mean, there's a lot there. Okay, but we're gonna slim this down pretty quickly. I need you to give me a result to that highlighted piece. That's where you got to start. You can almost kind of treat that square root like a set of parentheses. Like, hey, work inside of here first. Because there's nothing there other than numbers, you should be able to get this all the way down to a single number. Okay? So this is kind of what you should have. The -5 is there. This is a 12. I'm looking to fill that spot. Hopefully we can get more than one person with the same answer. That'll make us feel like we're on the right track. What you got, Ben? 121. Can you agree with that? Agree with that? You did not have that? Okay. Okay. So 5 squared. How much? 25, right? Here, you can treat this as a -4. So in your calculator, what is -4 times 6 times -4?
I did minus.
What is that? If you did -4 times 6 times -4, 2 negatives in there should make a positive. So that's 96 and a 25 originally, right? So that's where the 121 comes from. Okay? All right. So 121. Aiden?
I got 11, but I also put it like.
Okay. So that's my next step, right? Because I have yet to actually apply the square root. So from here, and a lot of these steps can be combined when I get a little bit more comfortable with what I'm doing. All right. So I'm now at the statement that says x is equal to -5 plus or minus 11 divided by 12. Square root of 121 is 11. Or the square root of 121 is -11. So that's how I end up with two different answers. Okay. Remember, graphically, we already knew what those answers were going to be, right? Here's how they come. My first one is going to be -5 plus 11 divided by 12. Yes, sir.
So are you always going to have 2 answers?
Okay, we'll talk about that. Not always. That's a good question. And the other one then is -5 minus 11 divided by 12. These two things should produce my two answers. Now, you're working on a fraction, so you're going to need an answer to the numerator before you divide it by 12. So don't just type it in your calculator in one string, because you'll end up, your order of operations will fail you. You'll do the division first, and that's not right. Okay. So on the top, what do you get? You get 0.5, right? Because the numerator of the first one is 6, and 6 divided by 12 is 0.5, or 1/2. In the bottom one, no. What's -5 minus 11? -16. And then -16 divided by 12 is that -1.3 repeated. Okay?
Why don't you change
Are you okay?
Yeah, I
Okay.
changed the bottom 5 to positive.
Oh, okay. So the only part that's switching here, right, is going to be that square root, because the square root of 121 has the possibility to be a positive 11 or the possibility to be a negative 11. Now, Kyler asked a great question. He said, is there always going to be two answers? Think about it like this. If I had a graph, like if I had a graph that had a parabola on it, how many answers does that picture have? It has two. How do I know that? Because it crosses twice. Can you envision a situation where that picture doesn't cross the x-axis twice?
Or the formula is flipped the other way.
Yeah.
So it's under the edge.
Sure. Right? If this picture, if I flipped it vertically, and then you said it was down here, that doesn't cross at all. Right? So there's no solution there. Or obviously the third possibility would be if it just barely touched. If it just touched the x-axis, then there would be one solution. So somehow this quadratic formula has to play that same idea. So when you said, is there always going to be two? The answer is no. And so that's where that discriminant, we'll talk about more about that in a second, how that comes into play. What's up?
So can we use like Desmos and then type it in?
Okay. So if the question originally says, hey, solve this quadratic, then the canvas is open, right? I could factor it. I could Desmos. I could use it. I could do whatever I want. If I'm asked specifically to do something, well, then now you've kind of locked me into a certain path. You know what I mean? So it depends. Is this the quickest way? Absolutely not. Right? And 20 years ago, before Desmos existed, this was like your go-to option to solve anything, because factoring was only going to work in certain situations, especially if the numbers didn't work out to be something that were like something that played nice or something that was divisible. The quadratic formula would handle that. But now technology has kind of played a bigger role. I can still do it. Okay. But I can't eliminate this from you right now because I can't guarantee it's not going to be asked of you. All right. And I want to, I'm not going to ice you out on that and leave you hanging, right? Because I think there's a better method. I do think there's a better method, but they didn't take this one off the table yet. So, long story, right? Sorry. Okay. So let's try this one here. If you want to go on your own and give it a shot, if you want to stay with us, okay. So either way, if you want to run it and see if you can figure it out, go for it. But if you're staying with us and you're thinking about this example, the first thing is we got to move everything to one side. That's never going to change with a quadratic. Okay, it's always got to be equal to 0. So I probably would just move the 3. All right, and that leaves me with 0 is equal to negative 3x squared plus 5x plus 2. Okay, you have to force something into being 0. Biggest mistake I'm going to see is you guys are going to make it equal to 0, but you're going to forget to change the sign when you move something. You're just going to put the 3 over there and call it positive 3. You know what I mean? So if you're going to move it, please understand that moving it changes its sign. So don't shorthand that step and then forget how that takes place. Okay. So if you have it equal to 0, what's up? What's up?
So how you put the negative 3x
Yes.
squared in front?
Yep.
I put it there, but like if you were to put it somewhere else, would it mess it?
Okay, so remember this. Which value is associated with A? Which one is associated with the A? It's the one that is the x squared. If I put the 3x squared, the negative 3x squared, excuse me, if I put it at the end, it's still the A value. So chances are, though, if you put it somewhere other than at the beginning, what are you probably going to do? Probably going to mix up what letters go where. So my suggestion would be put it in standard form, put it in the right order, kind of help yourself. Okay. So it still starts opposite of B. So that's negative 5 plus or minus. Now this square root that we need to figure out. You think you already have an answer? Okay. So we're talking B squared. So that's 5 squared minus 4. A is a negative 3 and C is a 2. And the whole thing is divided by 2 times negative 3. Okay. where do you start? I don't care if you're with me right now or if you're moving ahead. Where do you start? In the square root. So I'm going to highlight that same piece that we highlighted the last time. That's the part that I need to get an answer to first. Some of you guys are going to grab your calculator, type it all in one foul swoop, hit enter, and hope. Right? Let's be careful and make sure that what I have is what I'm actually supposed to have. What?
So is it -4 or is it -4? Is that a dumb question?
No. But to be honest with you, it's both of those things. If you want to think about this as minusing this set, okay, then you have a 4, you have a -3, and you have a +2. That result would be negative because it only has one negative in it. But you're about to subtract a negative, which ultimately means what? That it's going to turn into a positive. Or if you grab this negative with the 4, now you're saying negative and another negative, which is a positive. Yeah, so same thing. Tomato, potato. What's up?
When I put it in, like at first I put -4,
Uh-huh.
give me a decimal, but then when I put it -4,
Okay.
it gave me a
All right. So your calculator, though, see, your brain is treating it differently. Your calculator doesn't know that. When you hit the negative sign in your calculator, it's multiplying. If you hit the minus sign,
Yeah, I got a syntax error.
when you hit the minus sign, then your calculator recognizes what it's doing. So you can't rely on the calculator to make a decision for you. That's not going to work out. If I look at this and say, hey, listen, I see 2 minus signs inside of here, that's going to be a positive result. I know that. Then I'm not going to let the calculator get in the way. I can do 4 times 3 times 2. What's 4 times 3 times 2? 24, right? So 5 squared is 25. The other part's 24. I know that because there's 2 negatives, I'm adding those together. So 25 and 24, grand total of 49. Like, I'm in control of that situation, not hoping that I've let the calculator lead me to the right place. That's scary. Okay. So I know this result inside of this highlighted, okay. Inside of that highlighted part is a positive 49 in this case. So on my paper, I now have something that looks like that, hopefully. Right? I'm going to take the square root of 49 and I'm going to get 7. Okay. So my next statement really looks like this. And again, once you start to pick up the pace of how this is laid out, do I need every single one of these little steps? No. And some of you are probably thinking that right now, like, why am I writing all these? Well, once you have it, then you understand it. When you don't, you need those along the way. And then once you get there, you're in great shape. Now, this still has 2 answers.
Have 2 and -0.32.
Okay. So my first statement here, though, -5. That's okay. -5. Yeah, okay. +7 divided by -6. And then the other one would be -5 minus 7 divided by -6. So this top one is -0.3 repeated, or maybe you have -1/3. You could have that as well. I don't believe negative is, oh yeah, negative, because that's a 2 on the top. Okay. And then on the bottom, that's -12 divided by -6. So yes, that is 2. So there's one answer, and there's the other answer. Okay, so if I graphed it, I would expect to see this picture cross the x-axis how many times? Twice, right? Do I know where it would cross? I sure hope so, right? It would cross at 2, and it would also cross at -1/3. Yeah, but they would be on the x-axis. I agree with you. Okay, so both of these examples produce 2 answers, right? How is it possible that I could produce something other than 2 answers? You have an idea?
The inside of the square root thing, if that produces a negative.
Okay, so we've seen the same option twice right now. Both times that square root has been positive, and that's produced 2 answers, right? So kind of thinking over here on the side, this b squared minus 4ac, what's up? Okay. When this result was positive, I got 2 answers. But there's other options for this b squared minus 4ac other than being positive. Jack said it could be, what if it's negative? The part that was under the square root, the b squared minus 4ac, the first time we did it, what number was underneath there? No. What number? Yeah. What number was underneath here? 121, right? So that number, what's that? Yeah, yeah. So yes, this b squared minus 4ac, right? If it's positive, then ultimately you'll end up with 2 answers because you have to do the positive version and the negative version. What if when you add this up, it comes out to be a negative number? Go ahead, pick your calculator up. Square root a negative number and tell me what you get. Type in the square root and then put a negative number in there and tell me what you get.
Domain error.
You get an error.
Non-real answer.
Yeah, not real, not possible. Why is that?
Because it's unconscious.
Why can you not square root a negative number? Do you know?
I was thinking because like
The parabola? Yeah.
that since its position, it's gonna have the two things that pass the x-axis and then a couple.
Okay, so you're kind of thinking of it in a graphical sense? Yeah.
Because you have to multiply the same number together, and if you multiply two negatives, it's positive. It's positive.
Okay, so when you have a square root, it's got to be the same thing twice. That's the definition of a square root. It's that identical factor. Well, you can't get to a negative number with an identical factor. You can only get there with a positive and a negative. It's the only way you can make that happen. So because it's not possible, how many solutions will there be? None. Okay, so if that value that is under the square root comes out to be negative, no answer. Can we link this all together? Anna, what's up?
So, like, if it comes out negative, you just have to do the negative.
Yeah, it's like graphically speaking, it never crossed the x-axis. There was no answer. It's not factorable if you're thinking along those lines.
How come you have a third set?
Yeah, well, sure, think about it. If I'm thinking about how many times it can cross the x-axis, I know that it can happen twice, can't happen at all. The only other possibility is that it happens once. So somehow in this last scenario, it comes out one time. Well, if this thing was positive, if the b squared minus 4ac was positive, I got 2 answers. If it was negative, I got no answer. There's only one other possibility.
Zero.
What if it's equal to 0? Okay, just one. Now, this b squared minus 4ac has a name, and it's called the discriminant. All right, so kind of follow this picture over here. Watch how this works. If you think about the quadratic formula, it is the opposite of b plus or minus the square root of my discriminant, that b squared minus 4ac, the part I have to do first anyways. And the whole thing, right, is divided by 2 times a. I have to do this part first. But when I complete that discriminant, there are really 3 possibilities, and I just need to be aware of what I'm actually looking at. If that value comes out to be positive, like this third example down here, then I know that I'm out there searching for 2 answers. That's why I'm going to split it and write the positive and the negative. I'm going to get my 2 answers. If it works out to be a 0, then that means my vertex is what's touching, okay? AKA, it's a perfect square. That's what's happening there. You only get 1 solution. You don't get 2 solutions. And down here, if you get a negative, then it doesn't work at all, okay? Now, there's 3 questions on the bottom of your homework. We're going to do one of them together right now, kind of following this idea. All right, so Quinn, pick either number 4, number 5, or number 6. I don't care which one you choose. Will you say it louder? 5. Will you read me what number 5 says, please? Plus 9 equals 12x. Okay. Can you, what do you have to do with this equation before you do anything else? Anna? Move the 12x. Now, when I move it, this is going to go right back to our conversation, Aiden. Where am I going to move it? Good. I'm going to put it in between the 4x squared and the 9, right? That's where it falls in line according to its standard form. Now, Anna, you said I'm going to subtract it. So when I move it to the other side, it becomes what? It becomes a negative. So my new equation says 4x squared minus 12x plus 9 equals 0. Okay. I am not asking you to find the answer. All I'm asking you here is tell me how many answers there's going to be. And the discriminant will tell me that result. So all I'm looking at over here on this sideboard is the part that's in red, just the piece underneath the square root. What is b in this problem? It is negative 12. So if I was just doing the discriminant, the b squared minus 4ac, the only part I would be looking at is negative 12 squared minus 4 times a. What's a? A is 4, and c is 9. Okay. If this answer comes out to be positive, how many solutions to my problem are there? 2. If it comes out to be negative, how many answers are there? Ooh, none, because you can't square root a negative number.
9.
If it comes out to be 0, how many answers are there? 1. Okay, so what I'm looking at right now is what's the answer to this? Now you be careful, because if you square a negative number, what do you get? You get a positive, so you better be using parentheses. If you just grabbed your calculator and typed negative 12 squared, your calculator's going to screw that up because you screwed up. Okay, it doesn't get to think. What is negative 12 squared? 144. 144 minus, what is 4 times 9? Help me out, I don't know. What is it?
It's, well, negative 4 times 4 is negative 16 times 9 is negative 100.
Okay, so it's minus 144. Okay. Okay. So that result is 0, which means how many answers are there to this problem? There is 1. All right? Because if we go backwards here a second, let's just assume for a second that this problem here, that my discriminant, this piece under the square root, if this was not a 49 like it is in that problem, if it was a 0, then down here where I see a 7, I wouldn't write 7, I would have a 0, right? I wouldn't split this into 2 parts. I wouldn't write negative 5 plus 0 divided by negative 6 and negative 5 minus 0 divided by negative 6. Why would I not put the 0 in there twice? Well, not that it would cancel out. You'd get the same answer. If you had negative 5 and you added nothing, or if you had negative 5 and you subtracted nothing, what's changed? Nothing. So you don't get 2 answers. You only get 1. All right. And then obviously if that number is negative, you're just dead in your tracks anyways, because you can't take the square root of a negative number, right? That means there's no answer. Okay. So the use of the discriminant kind of leads me to possibilities. Okay. So we're going to look at one example and then we'll be done about how that can come into play. All right. So check out this example here. We can skip those because we looked at stuff off your homework. Okay. So try this. Okay. Yeah. This is supposed to be about John Lewis. I forgot it. There's no H in there. So before 9th period, I got to take the H out so he knows I'm talking about him. All right. That's me on the other side, ready to block his shot. Okay. That's what I do in my free time. I go to Sky Zone. I just wait for kids to come try to dunk, and then I just block their shots on the trampoline.
you if you guys want to just check that.
I'm hurting the shoulder. All right, so here's the question. John claims he can spring from a trampoline to dunk a basketball. All right, his height, h, in feet can be modeled by the equation h equals negative 16t squared plus 22t plus 2, where t is time in seconds. Use the discriminant to determine if John can reach a height of 10 feet. Now, how does the discriminant, like, how's that going to lead me to knowing whether John can get to a height of 10 feet or not? And knowing that there's either two answers or one answer or no answers, how does that play into 10 feet? Any idea?
Like 10 feet in the
Well, I am going to do that, absolutely. I'm going to take this 10 and I'm going to put it right there. But how, do you have any idea how this is going to work? Okay, good. So let's say this number comes out to be a positive. That means John somehow got to 10 feet twice. How is it possible that he got to 10 feet twice?
Jump twice.
Because he what? Okay, so let's assume that this line right here represents 10 feet. If John was able to get 2 hits at 10 feet, then that must mean that his picture crossed 10 twice. Okay? Now, what if, bless you, what if we find out that the discriminant has a value of 0 and means that there's only one answer? So how do you only hit it once? How do you only hit 10 feet one time? Not that you don't jump high enough, you don't go higher than 10 feet. So graphically, it might look like that, where he just got to 10 feet, right? This is the kid who is down in the gym talking about he's going to dunk, but he can barely touch the rim. Do you know what I'm talking about? You're like, I'm so close. I'm like, dude, you're not even close. You just barely touched it. You got to get your whole hand and the ball above the rim, right? So touching 10 feet, does that mean you can dunk at 10 feet? No chance, right? Now, what if this number comes out to be negative? Then John got no bounce, right? He's down here somewhere and he never hit 10 feet in the first place. So the discriminant can help me to answer this question by really doing what Caitlin said originally and saying, hey, what if I put a 10 into this problem? Like, that's what I'm asking. Can he get to 10 feet? And we're going to find out if it's positive. He's got some bounce because he can get over 10 feet. He hit it twice, once on the way up, once on the way down. Or he just barely got to 10 feet because that was like his max. Or he's got no bounce and he didn't get to 10 feet at all. So, better go to that next level hoop. You know what I'm talking about? That middle one, or maybe that kid one down at the bottom. You know what I'm talking about? Okay. So that's kind of, what we're thinking about when we look at this question, but it all comes down to setting this up. And the question is, if negative 16 t squared plus 22t plus 2 represents his ability to be able to bounce, then setting it equal to 10 asks, can he get to 10 feet? Now, I can't leave it set equal to 10. I got to set it equal to 0, which means I got to take the 10 and I got to move it. Where do I put it? Put it with the 2. So if you move the 10 over here, now you're subtracting it, so it's not going to be a 12, right? It's actually going to be a negative 8. Okay. Now, just like the beginning of how the quadratic formula starts, the discriminant, the piece underneath the square root, is where I'm going to begin. So b squared minus 4 times a times c. It's going to come out one of 3 ways. It's going to come out positive, it's going to come out negative, or it's going to be equal to 0. Those are the only 3 choices. Unless you goof it up and your calculator says error. That's a you problem. Okay? So b squared minus 4 times A times C. Does that result come out to be positive, negative, or 0? Because that tells me what John's able to do. I have no idea what 22 squared is. I have no clue what 4 times 16 times 8 is. So you're going to need to help me. Can you give me 22 squared? Actually, I probably know that. Is that like 484? All right. Now, just looking at what's on the other side, negative, negative, negative. So this whole thing is going to be a minus something. Okay. Minus 512. You agree with that? Okay. I'm actually going to stop right there. Because that number that comes out of the result of that is what? Is negative. Which tells me no solution. Means John Boy got no bounce, okay? He is not able to get 10 feet even on a trampoline, okay? Now, if I change this 10 to a 9, then that changes this problem. And that may turn this into a positive. If it turns it into a positive, then he could get 9 feet. Ain't no reason to change it to an 11 or a 12, because if he ain't making 10, he's not making 11 or making 12, right? I mean, that's not happening. But the discriminant allows me to be able to give an answer to that question without actually finding solutions. Wasn't what I was asked to do. Okay? So quadratic formula can use it to find solutions, right? The discriminant can also be used to determine how many solutions I'm actually looking for. All right? On the front, there are 5 questions left because we did one of those 5 together. And there's 2 questions on the back. One of them is like identical to this question. And the other one is basically just using the quadratic formula, but with words to start out. So you kind of got to sift through that a little bit. All right? Any questions right now?